Hello viewers and welcome to my YouTube channel. Today, as usual, like any other day, we are going to continue with our normal business of the day, that is solving mathematical equations. But before then, if you know you are watching my video for the first time and you know that you haven't subscribed to my YouTube channel, kindly pause this video and hit the subscribe button and also turn on the notification bell so that anytime we upload video, you will be notified. Thank you so much. Our today's challenge is going to be a serious one. 2 raised power of x minus 3 raised power of y is equals to 12. I don't know why sometimes we restrict ourselves or we limit our field of thought to only one variable, one equation, or two variables, two equations. Sometimes we can have as many as 2, 3 different variables or unknowns in a single equation. In our today's class or tutorial, we are going to look at 2 different unknowns or variables in a single equation. That means x and y. So let's see how we can find the respective value or values of x as well as the value of y. So follow me, let's solve the equation together. 12. In an equation, whatever you did to the right hand side, we must have to do it to the left hand side. That is in a normal cases or in a normal situation. But in some special cases, there are certain things you can do to one side which might not necessarily affect the result of the other side. For example, I may decide to multiply the left hand side by 1, which I know that definitely will not affect the result of the right hand side. I may decide to square or take the power of the left hand side by 1, which I know and I believe will never affect the result of the other side. So I have 2 raised power of x, I have 3 raised power of y. If I am to multiply the whole content of the left side of the equation, that means I must have to square the content of the right hand side as well, which is going to give us an error. So I want to carry out an operation to the left hand side of the operation equation in such a way that it will not affect whatever that is in the right side of the equation. What I'm saying here is, if I have 2 raised power of x, everything raised power of 2 over 2 minus 3 raised power of y, everything, let me put it well, three raised power of y, everything raised power of 2 over 2 is equals to 12. And when we look at this, I change nothing to the result of 2 raised power of x and 3 raised power of y, because 2 over 2 is 1. So 2 raised power of x raised power of 1 is still the same. 3 raised power of y raised power of 1 is still the same. That means I did not change anything to the result of these 2 terms. So remember, in one of the laws of indices, that whenever I have a raised power of m multiply n is the same thing as a raised power of m n. So when we succumb to this rule, we can rewrite these 2 terms based on this rule. That means I can rewrite 2x over 2 raised power of 2 minus 3 raised power of y over 2 raised power of 2 to be equals to 12. So in order to ease the solution, in order to be more focused, let's introduce an unknown or unknowns, 2 different unknowns that will represent these 2 different values, 2 raised power of x over 2 and 3 raised power of y over 2. So let A represent 2 raised power of x over 2 and B represent 3 raised power of y over 2, so that anywhere I see 2 raised to the power of x over 2, I put a, and anywhere I see 3 raised to the power of y over 2, I put b. Hope I'm communicating. Very interesting. That means rewriting this means a squared minus b squared will be equals to 12. Okay, but we remember, without stressing ourselves, we remember that whenever I have x minus y, x squared minus y squared is the same thing as x plus y and x minus y. So if I have this and we are to second by this, that means I can write this a squared minus b squared based on this format. That means I will have a plus b, a minus b to be equals to 12. So when we look at this, 12 can be written as 3 times 4, because 3 times 4 is 12. So if 3 times 4 is 12, and it can be equals a plus b and a minus b. A plus b, a minus b is equal to 3 times 4, sorry, not times 2. 3 times 4 is 12. But when we look at it, the sum of a and b must be greater than the difference of a and b. If I said difference in mathematics means subtraction, a plus b must be greater than a minus b. That means a plus b is greater than a minus b. And if that is the case, that means a plus b, a minus b is now equals to 4 times 3 and not 3 times 4. You see, I interchange them. On a normal ground, 3 times 4 and 4 times 3 is the same. But in this case, you need to swap the position in order to have the equation satisfied. So that means a plus b is equals to 4, which we call equation 1, and a minus b is equals to 3, and which we call equation 2. And this is a simultaneous equation which we must have to solve for a and b simultaneously. So we have different approaches to solving simultaneous equation, either substitution, elimination, or graphical method of solving simultaneous equation. Someone may decide to solve this equation by matrix form, and even in matrix we still have various methods of solving simultaneous equation. But for the purpose of this class, this tutorial, we are going to solve this particular simultaneous equation by elimination method. So I want to eliminate these two common terms because the coefficient of these two is 1. So in order to eliminate them, let me subtract the two equations. Subtracting the two equations means this equation minus the other equation. So a minus a is 0. Then b minus minus is plus. That means b plus b is 2b is equals to 4 minus 3 is 1. So I'm looking for b. That means I need to divide both sides by 2. By 2. These 2 will go with these 2. B, of course, is 1 over 2. So, but in equation 1 says a plus b is equals to 4. So, having obtained the value of b, we can now use this equation to substitute for the value of a. And someone may decide to ask, why equation 1? You must not necessarily use equation 1. You may decide to use equation 2, and you will still arrive at the same answer provided you follow the steps correctly. So having gotten the value of b, we can now use it to substitute. So now a will now be equals to 4 minus 1 over 2, and a will now be equals to 4 minus 1 over 2. 4 minus half is remain 3.5, and 3.5 will be 7 over 2, and this is the value of a. So now our value of a is 7 over 2, and our value of b is 1 over 2. This and this are very important in getting the value or values of x and y. So let me clean here. So but we recall that in this step we let a to be raised to the power of 2 raised to the power of 2 to the power of x over 2. So if I have 2 to the power of x over 2 is equals to a, and my value of a is 7 over 2. So instead of this a, I will now say, okay, 2 raised to the power of x over 2 will now be equals to 7 over 2. This is another equation which we must have to solve. But thankfully, we only have one unknown. There's no way I can make the two bases to be the same. To the left side, I have 2. To the right side, I have 7 over 2. And there's no way I can make the 2 to be the same. What I have to do is to introduce common log to both sides. So now, I want to introduce log to base 2 to both sides. So, log to base 2 of 2 raised to the power of x over 2 is equals to log to base 2 of 7 over 2. But in one of the laws of logarithm, whenever I have log to base a of b raised to the power of n is the same thing as n log to base a of b. So, going by this, that means I can rewrite the left-hand side of this equation based on this format. So, let me do like this. So, writing this based on this format will be x over 2 log to base 2 of 2 is equals to log to base 2 of 7 over 2. But still, in one of the laws of logarithm, whenever I have log to base a of a is equals to 1, this is what we call log of common basis or log of the same basis. So, going by that, that means this log to base 2 of 2 is equals to 1. So, that means x over 2 is now multiplying 1, which is x over 2. So, it's x over 2 is equals to log to base 2 of 7 over 2. Still, in one of the laws of logarithm, whenever I have log to base a of b is the same thing as log b over log a. So, going by that, we can write our equation as x over 2 to be equals log 7 divided by 2 is 3.5. So it's 3.5 all over log 2. So x over 2 is now equals, let me use calculator, log 3.5 is 0.5440 all over log 2 0.3010. So x over 2 is now equals this divided by this will be equals 1.8075. So x now be equals to 1.8075 times 2. So x will now equals this times 2 will give us 3.6. So this is the value of x. So how can we now get the value of y? So to get the value of y, we recall that at this point we let b to be 3 raised power of y over 2. So let me clean this. B is equals to 3 raised power of x over 2. And if the value of b is 1 over 2, that means 3 raised power of x over 2 is now equals to 1 over 2. And the same case that happened when we were looking, this is y, this is y. The same thing that happened when we were looking for the value of x, we introduce common log. So also we do it here, we introduce common log to both sides. That means we'll have log to base 3 of 3 raised power of y over 2 is equals to log to base 3 of 1 over 2. So that means, going by one of the law I cited when we were looking for the value of x, that I can have y over 2 here multiplying log to base 3 of 3 is equals to log to base 3 of 1 over 2. So let me clean here. I can also clean this. So we can have y over 2. This is log of the same basis, so log 3 to base 3 is 1 is equals to log 0.5 all over log 3. So y over 2 is now equals to log 0.5. Multiplying 2. So y is now equals to this value times 2 minus 1.26. So this is the value of y. So now the value of y is equals to minus 1.26. So let's check and see whether 3.6 as the value of x and minus 1.26 as the value of y will satisfy this particular equation. That means I'll have 2 raised power of x, which is 3.6 minus 3 raised power of y minus 1.26. So 2 raised power of 3.6, this is 12.1257 minus, this is the same thing as 1 over 3 raised power of 1.26. So we'll have 12.1257 minus 1 divided by this is 3 to the power of 1.26, 3.99. So 1 divided by 0.9, 1 divided by 3.99. So I have 12.1257 minus 0.25. So minus 12. So we can see that this is 11.875. So which is approximately 12. So we can see that 3.6 as the value of y, as the value of x, I mean, and minus 1.26 as the value of y satisfied this particular equation. For more content like this and many more, kindly subscribe to our YouTube channel. Bye.